Hello there and welcome to a brand new lesson. This is Happy Your Numbers, where we learn maths the easy way. In this lesson, we want to be able to define a geometric sequence and identify its common ratio, R. At the end of it as well, we should be able to test whether a sequence is geometric by checking for consecutive ratios. We should be able to use the geometric term formula as stated to find any term and then find the first term A and then the common ratio from given information. And then finally, we should also be able to distinguish between an arithmetic and a geometric sequence confidently. Without much ado, let's quickly look into it. Let's start first of all by looking at what makes a sequence geometric. When we say a sequence is geometric, it simply means the ratio of any term to the term before it is always the same constant. Take note, we are talking of ratio. So the ratio of what? The consecutive terms should be constant. And this is what we call the common ratio. How do you find the common ratio? So let's say you have a sequence. So you have a sequence U1, U2, U3, and U4, which continues indefinitely. Then to test whether or not a sequence is what? A geometric one, you are going to divide U2 by what? U1. If the answer we get is the same as dividing U3 by U2, which is also the same as dividing U4 by U3, where we call it what? R, then we say it is a geometric sequence. Now, this R over here's value affects the kind of sequence we have. So first of all, when R is greater than 1, then the term grows rapidly. We say that each term is larger than the last term by an increasing amount. A typical example is with 2, 6, 18, 54, and then on and on and on. If you want that R, then it's going to be 6 divided by 2. That is a 3. It is the same as 18 divided by 6, which is also a 3, and then 54 divided by what? 18, which is also a 3. So in this case, where we have our R being equal to 3, which is greater than 1, we see that the sequence is growing rapidly. On the other hand, if you have your R, which is between a 0 and 1, that is to say R is less than 1 but greater than 0, then you are going to realize that the sequence gets smaller and smaller and then it approaches 0. So an example, if I have a sequence where my first term is 100, followed by a 50, followed by a 25, then followed by what? On and on and on. You realize that the term is gradually reducing. It is getting smaller and smaller till we get towards 0. So in this case, R becomes a what? A 50 divided by 100. 50 divided by 100 is what? 1 over 2. Or a 25 divided by 50, which is also 1 over 2. And as you can see, it is reducing in magnitude from 100 to 50, 50 to 25, in that order. The last thing worth noting here is that for R, the ratio, the common ratio, can never be equal to what? 0. And it can also not be equal to 1. You see, if it is 1, then it seems, or it simply means every term is actually the same. Every term is the same. And then technically the geometric, it is technically geometric, but then it's actually trivial. So we don't let our R be what? 0, neither is it 1. So one other name we use for geometric sequence is simply an exponential sequence. It is exponential because the general term involves a power of R, which we would see very soon. So let's look at the general term formula of an exponential sequence. So talking of the general term formula, we see that for a geometric sequence with the first term being A and then the common ratio being r. Then the nth term is found by what? Multiplying your a, as you see over here. So you multiply your a by what? R to the power n minus 1. This is the general formula of a geometric sequence. You remember that of a linear sequence. It is very different from what we have over here. So the a is our first term, r is the common ratio, and then the n is the position number. So if you went through the previous lesson, then I do hope you have really understood the arithmetic. With that, let's look at the difference between the two. So if we look at the arithmetic sequence, the operation we actually work with is to add d each time. That is what sums up to give us the general formula. Meanwhile, on the other hand, for geometric, we actually multiply by r each time. See? And to test whether a sequence is arithmetic, we said we should find the difference. If the difference are actually equal, then we can arrive at the fact that it is what? Arithmetic. But for geometric, we don't find the difference, but we rather use the ratios. If the ratio of the consecutive terms are the same, that is where we say they are geometric. And take note of the formula. So for the general term of an arithmetic sequence, we said it is a plus into bracket n minus 1 multiplying d. But out of geometric, we say it is what? A times r to the power n minus 1. Talking of their graph, if you are to plot out an arithmetic sequence, you get a straight line. But for geometric, you are going to get a curve, in other words, an exponential. So now that we know these differences, let's try and solve some questions on the geometric. So as we usually do, our first question will be very, very basic. Then we start climbing the ladder. And I'll always advise you pause the video, try as much as possible to solve or come up with your own solutions before you come and then check my suggested solution. Our first question says we have to confirm the sequence is geometric and state A and then R. So since we are confirming, we need to state the condition for what a sequence to be geometric. So we know that for geometric, what should happen? Then the u of n plus 1 divided by u of n should be equal to what? R for all of them. So for this case, let's try with our first one. U2 divided by U1 becomes what? 12 over 3. And 12 over 3 gives us what? A 4. Let's try the next one. So we have U3 divided by U2. That also gives us a 48 over 12. And 48 over 12 also gives us a 4. We can also try for 192 divided by 48. And we are also going to get a 4. So if this was to be our R1 and then this R2, then we can say that since R1 is equal to R2, that is to say, since the ratios are the same, then it simply implies that the geometric or the sequence is a geometric one. And with that, it says you should state A and then R. So we can say, therefore, our A is equal to 3, then the R is equal to what? 4. As simple as that. Let's look at our second question. For our question 2 over here, it says, find the seventh term of the geometric sequence. There's our sequence. We have 5, 10, 20, and then 40. And first of all, we even need to determine whether or not it's a geometric sequence. And I do hope by now you can do it. But since we've been told it's a geometric sequence, there is no need showing it. We have 10 divided by 5, which gives us a 2. 20 divided by 10, which gives us a 2. Then 40 divided by 20, which also gives us a 2. Hence, it is geometric. Now, we know that for the general geometric term, that is UN, is given by A, then times R to the power n minus 1. You see? So with this, looking at our sequence here, we can say our A is equal to 5. And all we need to do is to solve for what? R. So we know R is obtained by dividing what? UN minus 1, UN plus 1 divided by UN. So that is going to be our R, giving us the second term divided by the first term. So 10 over 5, which gives us a 2. So with this, we come all the way here and see our general term is what? A, where A is 5. So 5, then times R. Our R is 2, so to the power n minus 1. The question asked us to find the seventh term. So it simply means that our n is equal to 7. If our n is equal to 7, then it implies that our u7 will then be giving us a 5 times 2 to the power n. In this case is what? 7. So 7 minus 1. Evaluating, we have 5 times 2 to the power 6. That is the 7 minus 1 over here. And we know 2 to the power 6 gives us a 64. So multiplying it by 5, we are going to get a 320. So we can conclude by saying, therefore, the seventh term. Therefore, the seventh term of the sequence is what? 320. As simple as that. Let's then look at our next question, which is question number 3. So for this question here, it says, write the general term for all of these we have here. That is 100, 50, 25, and then 12.5. And after which we need to look for what? The eighth term. So how do we go about it? First of all, let's check whether or not it is an exponential sequence. So if you have 100, if we have 50 divided by 100, that gives us a half. 25 divided by 50, that gives us a 5. Sorry, a half as well. Then 12.5 divided by 25 gives us what? A half as well. So that is to say that our UN plus 1 all over UN, which is equal to a 50 divided by 100, which is also equal to a 25 divided by what? 50, which is also equal to a 12.5 divided by a 25, is giving us a 1 over 2. And that is our R. You see? So we've gotten our R. Now if we have our R, we can then justify that it is an exponential sequence. Hence the general term UN is going to be given by A times your R to the power n minus 1. And by observation, we know our A is giving us 100. And we have solved for our R to be what? 1 over 2. Hence, substituting, we have our UN, that is the general term, being given as A, which is said is 100. Then times our R. In this case, our R is 1 over 2, all to the power n minus 1. And that is all. So this here is the general term. Now for U8, that is for U8, it simply implies that our n is equal to what? 8. So substituting, we have our eighth term giving us 100 times 1 over 2, then into bracket n, which is 8 minus 1. What this needs is what? Simplification. So simplifying further, we are going to get our eighth term being 100, then times 1 over 2 all to the power 7. Applying a little bit of indices here, our eighth term is just 100 times 1 all over 2 raised to the power 7. At this point, applying fraction, we have 100 times 1, which gives us 100, then all over 2 to the power 7. You have to evaluate this on a if you have to evaluate this on a calculator, you are going to get a 0.781 as your final answer. So we can say, therefore, the general term is giving us what? Un, which is equal to 100 times 1 over 2 to the power n minus 1. And then our eighth term, on the other hand, is a 0.781. Very, very simple, isn't it? Let's look at another one. Let's say one last one, then we take a word problem and we'll be done for this session. For the fourth question we have here, it says the second term of a geometric sequence is 18 and the fourth term is 162. We have to find A, R, and then the sixth term as well. Now, to solve this type of question, we first of all know that for a general geometric term, it is given as what? A times R to the power n minus 1. If we are being given the second term, U2, then it is what? An A, then times R, and then n minus 1. In this case, the n is 2. So 2 minus 1, and we are saying all this is equal to what? 18. You see, if you have to simplify, we have A, then R being equal to 18. The reason why it's now R is we have 2 minus 1. 2 minus 1 gives us 1. So we keep that over here. Now for the fourth thing, we can say U4 gives us what? A R to the power 4 minus 1. And we are being told that is equal to what? 162. So with that, we have our A then R raised to the power 4 minus 1, which is what? 3. And that is equal to 162. So this here becomes our first equation, and this here becomes our equation 2. And what do we want? We want our A, R, and the sixth term. First of all, we would have to solve these two simultaneously. So I'm going to call AR equals 18 as equation 1. Then AR to the power 3 equals 162 as our equation 2. And how am I going to solve? I'm going to say equation 2 divided by equation 1. That is to say, for the right-hand side, for the left-hand side of equation 2, A R to the power 3, let me divide it by that of equation 1. And we have to do the same thing also for the right-hand side. So that is 162 all over 18. We can then solve further. So we do that by what? Simplification using our laws of indices. So since they are dividing, then this A cancels out this A. Then this R reduces this by 1. and 8 divides itself once, and then it divides 162 9 times. Simplifying further, a is gone because it has been cancelled out. We are left with r to the power 2, which is equal to what? 9. If you want our r, you can just say r squared equals 9 can be written as 3 squared. And since the powers are the same, so since both equations have the same square, you can then say our r is equal to 3. Better still, you could find the square root of both sides here, and you still get r being equal to what? 3. So we have gotten our r now. How do we get the a? You can simply put r into any of the equations. For that matter, I'm going to put r into equation 1. So we would say put r into equation 1. And what was r equation 1? This was equation 1, you see. So substituting r, we have a, then times the value of r, which we know to be what? 3, being equal to what? An 18. And from here, we can make a the subject by dividing both sides by what? 3. So divided by 3 and then divided by 3. Where this 3 cancels out this 3, and we'll be left with what? A. So a equals 18 divided by 3. That gives us a 6. So we are almost done with the question. The question was, you have to find a, r, and then the set thing. But first of all, we need the general formula. So this simply implies that un is equal to a, which is 6, then times our r. We got our r to be what? 3 to the power n minus 1. Hence, if we want our set term, which is u6, where n is equal to 6, we have our 6, which is our a, times 3 to the power n, which is 6, then minus 1. Evaluating further, we have 6 times 3 to the power 5. If we evaluate this, we are going to get a 6, then times 3 to the power 5 gives us a 243. So multiplying 6 by 243, we have 1,458 as our set term. And that is all. So therefore, our a equals 6, r equals 3, and then our set term is equal to 1,458. As simple as that. Let's solve one last question, which is going to be a word problem. Our last question here says, a bacterial colony starts with 50 cells and doubles every hour. How many cells are there after 10 hours? Now, after how many hours will the count first exceed 25,000? This is a very nice question. Now, from the question, let's write out what we think can be our parameters. A bacterial colony starts. So if it starts, then this would be our first number of bacteria we have in the colony. So we can say our A is equal to what? 5. We are trying to model this, you see. So if our A equals 5, it says it doubles. Its doubling means what? The ratio after each R is 2. So our R is equal to 2. You see? With that, we can straight away even get our general formula. We know our general formula is given as un equals a to the power r raised to the power n minus 1. Okay, so ar to the power n minus 1. And simplifying, we have our un being what? A, which is 50. Then 50 times our r, which is 2 to the power what? And n minus 1. So we want the number of cells there would be after 10 hours. After 10 hours, what will n be? We don't know what n gave us this 50, you see. Or you can also say, since it is the first term, then n is equal to 1, you see. So n being 1 gave us what? 50. Then after 10 hours, it will simply means that we want the 11th term. Do you get this? On the first hour, we had what? 50. That is the starting. After 10 more hours, so after 10 more hours will be the 11th hour. You see? So from one, after 1 hour will be what? The second hour, after 2 hours in that order. So after 10 hours is the 11th hour. And how are we going to work that? It is going to be what? A 50 times 2 to the power 11 minus 1, which is a 50 times 2 to the power 10. You see? We know 2 to the power 10 gives us a 1024. So if you multiply that by 50, we have a 51,200 cells. It means if the initial starting point was what? 50. After 11 hours, these are the number of cells we have to expect in the colony. Do you see that? And that becomes the first part of the question. But the second part is, after how many hours would the count first exceed this over here? So for our general thing, which we have gotten to be what? Un is equal to 50 times 2 raised to the power n minus 1. We want it to exceed. So for it to be greater than the number we have over here, that is 25k. This simply means we are solving for 50 times 2 to the power n minus 1 greater than what? 25k. So 25,000. Now, this simply means we want to make r the subject. We want to make n the subject. So making n the subject, let's simply divide both sides by 50. Dividing both sides by 50, we have 2 to the power n minus 1, which is greater than, these zeros takes out each other. Then 5 into itself once into 25, we have a 5 here. We have 5, 0, 0. This is what we have. So making n the subject, we can open this up. So that becomes 2 to the power n over 2 greater than what? 500. Which can then be written as 2 to the power n is greater than, we are multiplying both sides by 2. And this is going to give us 1,000. So 2 raised to the power what? Gives us 1,000. You see? With this, we would have to apply a little bit of logarithm. So we take logarithm of both sides to the base of 2. So that we have log 2 to the power n base 2, which is equal to log 1,000 base 2. Applying the laws of logarithm, this n comes to this side, so that we have n, then log 2 base 2, which is equal to log 1,000 base 2. Now, since this is the logarithm of the same base and number, we are going to get our n being equal to what? The logarithm of 1,000 to the base of 2. And evaluating that on your calculator, you get a 9.965. Hence, n is approximately 10. You see, so this is to tell us that It is after 10 hours, you see, that the number of cells are going to exceed 25,000. So that is going to be our conclusion. And this is actually the last question of this session. So as usual, I'll leave with some exercises so you try on your own just to test your understanding. So we have 5 questions, all from what we've done in this session. You have to pause the video and attempt before moving on. If there's any issue of concern, you can always let me know in the comment section. Let's have Beyond Numbers, where we learn maths the easy way. If this is your first time on this channel and you think it will be of help to you, you can choose to subscribe if you so do, so that anytime I release a video, you'll be notified as well. See you in our next lesson, and bye for now. Do stay safe.